So, which of the following is an effect of efferent arteriolar constriction? So, we'll solve this question in basically two parts. First of all, we will what happens to the changes in GFR. Okay, so factors affecting GFR. So, the GFR is directly proportional to afferent arteriolar dilatation and efferent arteriolar constriction. Okay, efferent arteriolar constriction, and then it is also dependent on hydrostatic pressure of glomerular capillaries. So hydrostatic pressure of glomerular capillaries and inversely proportional to oncotic pressure of glomerular capillaries. Okay, so this is the first part, and vice versa, it is inversely proportional to hydrostatic pressure of peritubular capillaries, and it is directly proportional to oncotic pressure of peritubular capillaries. So this is the vice versa. Then another part of this question, same question, is that the changes in afferent arteriole. So first we'll cover the afferent arteriole. Changes in afferent arteriole. So what happens is the afferent arteriole has to dilate so as to increase the GFR. So the GFR increases in afferent arteriolar dilatation, and the GFR and the renal blood flow also increases in case of dilatation, and it is directly proportional to the hydrostatic pressure of glomerular capillaries. Then the changes in efferent arteriole. Changes in efferent arteriole. In efferent arteriole, what happens is mild constriction to efferent arteriole. Mild constriction to efferent arteriole causes the renal blood flow to decrease. Okay, so it causes the renal blood flow to decrease, but the GFR increases. So this is the relation between the efferent arteriolar constriction and efferent arteriolar dilatation. The renal blood flow increases and the GFR decreases. So this is what happens. So in this question, we have to see the effect of efferent arteriolar constriction. So what happens is efferent arteriolar constriction, we know that it causes increase in GFR. So first option is ruled out. Then it decreases the renal blood flow. So we know that the mild constriction of the efferent arteriole causes the renal blood flow to decrease, although the GFR increases. So both these options are ruled out. Then the third one, it decreases the oncotic pressure in the peritubular capillaries. So what happens is that we know that efferent arteriolar constriction causes increase in GFR. So it causes increase in GFR. So the factors affecting GFR, we know that for the GFR to increase, the hydrostatic pressure of the glomerular capillaries have to increase, and the oncotic pressure of the glomerular capillaries has to decrease. So since the for increase in GFR, we have to have this oncotic pressure of the glomerular capillaries decrease. So here it should be the oncotic pressure of the glomerular capillaries that should have decreased in order to GFR get increased. So, but it is given in the question that the peritubular capillaries oncotic pressure decreases. So this is the incorrect option. So this is the answer here. Then moving to the fourth option, increase in hydrostatic pressure in glomerular capillaries. Yeah, this is definitely correct, because the increase in the hydrostatic pressure in glomerular capillaries increases the GFR, and the constriction in the efferent arteriole. Efferent constriction also increases the GFR. So both these options, in fact all these three options are in the favor of GFR increasing. So that's why third option is the answer here, and this is a very important question in physiology because it is asked every year, almost every year, the relation of um, this increase in GFR. So what happens is changes in afferent arteriole, dilatation and constriction. So dilatation causes increase in renal blood flow. It causes increase in GFR, and it causes increase in hydrostatic pressure of glomerular capillaries. And the constriction, it would be opposite. And for changes in efferent arteriole, it causes, first we'll see the dilatation and constriction. So we know that the efferent arteriole constriction causes increase in GFR, but it causes decrease in renal blood flow, and it causes increase in hydrostatic pressure of the glomerular capillaries. So the renal blood flow relation is different in both efferent arteriole and constriction and afferent arteriolar dilatation, though both these conditions causes increase in GFR, but it is opposite. So we know that both these conditions, that is the afferent arteriolar dilatation causes increase in GFR, and efferent constriction causes increase in GFR, but both are in opposite in case of renal blood flow. In case of renal blood flow, what happens is afferent dilatation causes increase in GFR, and efferent constriction causes increase in GFR. But in case of renal blood flow, afferent dilatation causes increase in renal blood flow, but efferent constriction causes decrease in renal blood flow. So these two conditions are same for GFR, but these two conditions are opposite for renal blood flow. This is the take-home point of this video, and this is in conclusion to this question that we have discussed here. So that's why 3 is the answer here. So I hope you got it right now, and thank you and have a nice day.